Hey everyone, welcome back to my channel, The Daily Scope. They're not telling you everything. NASA just greenlit a mission that will travel beyond our solar system. Not around Mars, not to the moon, but to the edge of the known sun's influence and into the unknown. It's called IMAP, the Interstellar Mapping and Acceleration Probe, and its goal? To map the invisible boundary between us and the rest of the galaxy. Why now? Why this mission? And why is no one talking about what might be waiting beyond that line? Scientists claim it's about studying solar winds and space weather, but some experts say there's more to it. Far more. There are rumors of strange particles, unexplained signals, and zones of complete radio silence just beyond the heliosphere. Places where our instruments go dark. What is it they're really looking for? And what do they already know? This mission could change how we see the universe, or even prove we're not alone. But before you accept the official story, ask yourself this. What lies just beyond the reach of our sun? And why is NASA in such a hurry to find out? Let's start with the basics. IMAP, the Interstellar Mapping and Acceleration Probe, is a mission launching in late 2025. Its destination, a point roughly 1 million miles from Earth known as L1, the first Lagrange point. From there, IMAP will stare deep into the outer solar system, collecting data on particles that come from the edge and beyond. Its primary goal, according to NASA, is to study the heliosphere, a vast bubble of charged particles and magnetic fields blown out by the sun. This bubble protects our solar system from harsh cosmic radiation and separates us from interstellar space. In a way, it's our invisible shield. But here's where things get interesting. The edge of the heliosphere isn't a clean line. It's chaotic, unpredictable, and alive. Voyager 1 and Voyager 2, the only spacecraft that have crossed it, sent back data that stunned scientists. They encountered unexpected magnetic fields, strange particle flows, and something they didn't anticipate at all, a region where cosmic rays seem to bounce as if being reflected. IMAP is designed to investigate this. But is that all? Why is NASA investing hundreds of millions of dollars into mapping an invisible region of space we can see with telescopes? What do they hope to find? Let's rewind for a moment. Back in 2012, when Voyager 1 crossed the heliopause, the outer boundary of the heliosphere, its instruments detected an eerie silence. The plasma around it changed. Magnetic fields shifted in bizarre ways. And, most curious of all, it passed through multiple layers of boundary regions, not just one. This suggested something profound, that the edge of the solar system might not be a thin membrane, but a dynamic, multi-layered shield with unknown properties. Some physicists even proposed it could act like a filter, or a gate. A gate to what? That's the part no one agrees on. Now enter IMAP. IMAP's instruments will capture high-energy particles known as energetic neutral atoms, or ENAs. These particles are like ghost messengers, created in the chaotic dance between the solar wind and incoming interstellar matter. By tracking their paths and intensities, IMAP can image the invisible. But again, why now? NASA claims it's to improve our understanding of space weather. And yes, that's important. Solar storms can knock out satellites, harm astronauts, and even shut down power grids. But scientists already have missions monitoring the sun itself, like the Parker Solar Probe and Solar Orbiter. IMAP is different. It's not watching the sun, it's watching what's out there. In 2019, a study from the University of Iowa revealed that mysterious cosmic rays were entering our solar system from an unusual angle. Not from the galactic center, and not in a uniform spread. Something was distorting their path. Something unseen. Could there be massive magnetic structures beyond the heliosphere? Or worse, could there be something emitting radiation or energy directed toward our system? Some researchers believe IMAP might help us detect signs of interstellar objects long before they reach us, like the now famous Oumuamua, the strange, tumbling object that entered our solar system in 2017. It was moving too fast, had an odd shape, and didn't behave like any known comet or asteroid. What if more of these objects are out there, hiding just beyond the edge, and IMAP is our early warning system? Another theory is even bolder, that IMAP could pick up signs of intelligent life. No, not aliens in flying saucers, but advanced civilizations that might leave detectable traces, like artificial particle patterns, directed beams, or energy emissions we can only detect at the solar system's edge. It's no longer science fiction. Breakthrough. Listen and other SETI-related programs are actively searching for technosignatures, and the heliopause might be one of the best places to spot them. Think about it. If an intelligent civilization wanted to observe us without entering our system, the heliosphere would be the natural place to stay hidden, just outside our solar bubble, undetectable until now. But what happens if we discover something? Will NASA tell us? Or will the data remain locked behind classified doors? There's another layer of mystery here: timing. IMAP's launch is aligned with increasing solar activity. The Sun's 11-year cycle is reaching its peak, meaning the heliosphere is more dynamic than ever. Some believe this cycle could briefly expose whatever S lurking just beyond the boundary, like a tide pulling back before a tsunami. Is IMAP being launched now because conditions are perfect, or because we may not get another chance? IMAP will also work alongside Voyager 1 and 2, still transmitting weak signals from the interstellar void. If something changes out there, a sudden burst of radiation, an anomaly in particle flows, these aging spacecraft might catch it too. Together, they'll form a kind of cosmic net. But here's a question no one seems to be asking. What if the heliosphere is not just a shield, but a kind of cosmic marker? What if other star systems have similar boundaries? And what if those boundaries are the way civilizations detect each other? Could IMAP be our first attempt at interstellar diplomacy or defense? It's possible we're poking into a region that no one dares disturb. Or maybe, just maybe, we've already been noticed. NASA says it's a simple science mission, just another probe to help us understand the Sun and its influence. But when you look closer at the timing, the goals, the technology, and the silence around the bigger questions, you start to wonder, is there more going on here? We're on the edge of something monumental. The boundary of our solar system isn't just an empty void. It's a frontier, a transition, maybe even a warning. And with IMAP, we're about to cross that line, not physically but in knowledge, in awareness. The next few years could redefine how we see our place in the universe. So now we ask you, what do you think lies beyond the heliosphere? Is it just dust, wind, and radiation? Or is there something else out there? Leave a comment and let us know your theory. And don't forget to subscribe to the Daily Scope, your front row seat to space discoveries, cosmic mysteries, and the secrets no one else is telling you. The universe just got a little closer.